So we want to find the producer surplus here if the price is set at $6. So we're told that the price is set at 6. We want to find, excuse me, we want to first find, how many are they going to be supplying if the price is $6. So we need to first find our X bar. Okay, so plug that into our supply curve. And we have a quadratic equation that we need to solve. Well, since we have a polynomial equation to solve, we need to go to our quadratic formula. So x would be negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. And so at this point we can go to a calculator and start computing each of those two results. So starting out, we get two results for our price, but one of those gets thrown away. You can't have a negative price. So 13.03. So we have two answers. It should actually be negative 23, but again, it's not going to matter. We do have our one, which is now going to be our X bar. Right, that's the quantity that they would be willing to sell. And again, that's in thousands, so it's really 13,030 of those products they'll be willing to sell at a price of $6. Once we know that price, we can then compute our producer surplus. Producer surplus, again, is the integral from 0 to that X bar, 13.03, and then it's our P bar, our price, minus our supply curve, whatever our supply curve is, and in our case, that's our equation, 0.01 x squared plus 0.01 x plus 3. Okay. So just the price minus our demand curve, or supply curve. Start working that out. Or again, if you have that numerical integral feature on your calculator, you can use that. Distributing that negative through, that'll be 6 minus 0.01 x squared minus 0.1 x minus 3. So rewriting that, that would be 3 minus 0.01 x squared minus 0.1 x dx. And so we go through and we do our antiderivative of each piece. 3x, and then for 0.01 x squared, you'd add 1 to the exponent, make it 3. So it's going to be 0.01 x cubed over 3. And then for 0.1x, add 1 to the exponent, divide by it, so it's going to be 0.1 x squared over 2, and that's evaluated at 0 and at 13.03. So just doing evaluating the definite interval, so we evaluated at the two endpoints, the top one, and then minus the bottom one. Again, minus the bottom one, minus the 0. Everything would be evaluated at 0. That would be minus 0. I just stopped working for a second. So 23.227. And so that would be our surplus, but again, X is in units of thousands, so our actual surplus would be $23,227. And that's how much producers would save by going with that price as opposed to some cheaper price.